structure of the airplane, the skeleton that underpins the shape of the aircraft. The fuselage structure is made out of aluminum formers, bulkheads, longerons, and stringers. The main landing gear requires to be made out of flexible steel to withstand the forces during hard landings. If we look inside the wings, we'll find ribs, which provide the airfoil shape of the wing. Spars running through the entire length of the wings accomplish great strength, and stringers to support the shape of the wing even more. The key point here is that the shape of the airfoil is very specific to preserve the flight characteristics of the aircraft and to produce lift efficiently and with the least aerodynamic drag possible. The entire structure is covered with aluminum sheets riveted to the skeleton. This outer skin will further increase the strength of the airframe. This is called the airframe, which is considered to be the entire structure minus the engine and avionics. The green color of the skeleton structure, sometimes yellow, comes from a primer layer of zinc chromate or zinc phosphorate. It is applied to prevent corrosion on the aluminum surfaces in most parts. Older models might not have this layer of primer and will have the original aluminum metallic look. This particular aircraft has wing struts to reinforce the joint between the wings and the fuselage. It attaches from the main spar to the lower front section of the fuselage. Because this aircraft has a high wing configuration and headroom space in the cockpit is limited, the full main spars cannot go through the cockpit, and instead there are a couple of spar carry-through channels that join the two wings together. Of course, these channels are not as strong as the main spars, but that's when the wing struts come into play to distribute the load and forces. On the exterior of the airframe, we'll see the static wicks or static dischargers attached to the sharpest points of the aircraft like the trailing edge of the wings. They discharge accumulated static electricity causing rip includes the engine plant. The power plant includes the engine, propeller, and other components. Different Cessna 172 models can use different types of engines, all of them very similar. In this model we're looking at the Lycoming IO360, a 4-cylinder horizontally opposed also moves the alternator to produce electricity. This is also a 4-stroke engine, which means that each pit 2 revolutions. At any given time, each of the cylinders in the engine is in a different stroke, meaning that there is always one cylinder in the combustion stroke, providing continuous power. The propeller is attached directly to the crankshaft, so that the power is directly transmitted from the engine to the propeller without any. It doesn't require as much maintenance and it's easy and cheap to replace. Like in many aviation engines, this engine is cooled by air, taking air from the openings on the nose of the aircraft and redirecting it through the heat-dissipating structure of the cylinder injection systems. The Lycoming IO is to provide a mix of air and mechanics than electronics. The goal of both systems is to provide a mix of air and fuel and air before it enters the cylinder. The amount of fuel that enters the engine depends on the amount of air that is passing through it, thanks to the Venturi effect, which generates a lower pressure that sucks the fuel from the discharge nozzle. The fuel injection system is more
now. In this video, we will explain the technology behind the jet engine in a logical, step-by-step manner. A jet engine keeps an aircraft moving forward using a very simple principle, the same that makes an air-filled balloon move. Yes, Newton's third law of motion. Just like the reaction force produced by the air moves the balloon, the reaction force produced by the high-speed jet at the tail of the jet engine makes it move forward. So the working of jet engine is all about thrust force makes an aircraft move forward, achieved by a combination of techniques. For this purpose, a combustion chamber is used. An atomized form of the fuel is burnt in the combustion chamber. Effective combustion requires air to be at moderately high temperature and pressure. To bring the air to this condition, a set of compressor stages are used to sustain combustion. The compressor and turbine are attached to the same shaft. You can see that the turbine blades have a special airfoil shape which creates lift force and make them turn. As the turbine absorbs energy from the fluid, its velocity moves forward. Modern aircrafts are used. The shaft of the outer compressor turbine passes concentrically through the